So we are going to discuss about the third chapter, which deals with the fresh concrete properties. In fresh concrete properties, we have already discussed the manufacturing process of concrete as per the IS code and various other guidelines that are used in the industry in the practical process. We have discussed that, and we have discussed regarding the batching, mixing, transportation, placement of the formworks, then the compaction of concrete, uh, finishing of the concrete. Also, we have discussed regarding the curing of concrete. Now, apart from this, we have discussed the various deficiencies that happen with the concrete, majorly the segregation that happens during the manufacturing stage of concrete. The segregation has three distinct parts like bleeding, latence, honeycombing. We have discussed all those things. These which are the deficiencies in the concrete, which will lead the concrete for deterioration, which can cause a deterioration of the concrete in the latter stages. So the durability of the concrete depends largely on how you take care of the concrete during the manufacturing stage. So one of the deficiency of the concrete or bad effect that can happen if the concrete is in the green stage and proper care is not taken is called as shrinkage. Shrinkage is nothing but the volume change that happens in the concrete. Now, we're going to talk about a particular case of shrinkage, that is the plastic shrinkage. So plastic shrinkage, again, it's nothing but the volume change, but why it is called as plastic shrinkage is because it happens when the concrete is in the plastic stage. That is, the concrete is still not completely hardened, so it will undergo deformation even when the small force is applied. So the plastic shrinkage or the shrinkage simply can also is also called as the pre-hardening or pre-setting shrinkage. It happens majorly because of reduction in volume of the concrete, and the major volume change happens because of loss of water. If the concrete is not completely stiffened and it loses water, so instead of forming voids, it will form cracks. The concrete will undergo cracking, and these cracks generally they run perpendicular to the surface, and where they will occur whenever there is a obstruction to the volume change. The obstruction to the volume change can be steel or large coarse aggregate particles. Now, whenever the volume change occurs, there is a downward movement happens with the concrete. Now, let's just go through the diagram here. See, this is a uh, schematic sketch or the sketch wherein you have concrete. So this is the concrete here, and black ones are the coarse aggregates. Smaller black dots are uh, sand. You have a lot of water in between, and also this is the steel which is present in the form. This is the initial top layer of the concrete. This could be the cover that we provide for the concrete. Now, whenever the concrete undergoes volume changes, it's going to subside because it does not have any chance of movement in these direction wherein the formwork is present, provided that the formwork is very hard and stiff, obviously it does not have any chance to go down either. So the volume change occurs because of the subsidence. So when the concrete subsides, now, now why it is going to subside? So you have water in the system. So due to vibration or due to the segregation, the latence comes up on the top. So that latence contains a lot of water. Majorly it is a mixture of cement and water. Also, there's a layer of water that can come up, which is called as bleeding. So this water, if the rate of bleeding is lesser than the rate of evaporation, because sun is going to be beating down on this uh, concrete. If this concrete is, we have done this concreting during the daytime, the water is going to evaporate out from the concrete surface. That is, if the rate of bleeding is smaller than the having smaller value than the rate of evaporation, water is going to evaporate out. So the concrete at the surface is going to lose water. When it loses water in this place, it tends to go down because whatever volume which was held by water, this this volume is going to go down. So generally, because we vibrate it and finish the concrete at the top surface, we have a lot of sand, cement, and water mixture. Not much of coarse aggregates are going to be present here. So this water, when it loses due to evaporation, the concrete subsides. So when it subsides down, means what? It's going to go down like this. Now here, whatever amount of concrete which was present here, let's say this was the amount of water, or sorry, amount of concrete which was present, is going down. So here it does not have much of a resistance, it can go down easily. Water will have a tendency to come up, okay, and it will be coming up as a bleeding water, and it will again be subjected to evaporation. So water will come up and the heavier material goes down. Now, as we have steel present here, the steel will not go down, but it will resist the downward movement of the concrete. So the concrete now, or the paste here, will not have any choice, and this material goes down here. This again will go down, whereas the material in this region above the steel will have a strong support of the steel, so it won't go down. So because these two parts are going down, the crack is going to form on the surface of the steel. The crack is going to form here, and similar sort of thing can happen when you have an large aggregate piece present. So this aggregate piece can actually lead to cracking. So this crack can occur here or here. So we get a crack which is perpendicular to the surface of the concrete, like this. So the concrete here undergoes the cracking. Okay. So these aggregates are pretty deep, so might be possible that the deformation will not lead to cracking, but wherever you have aggregates which will support the concrete above it, that is, they will not let the concrete subside in this region, because the concrete which is aside that it is subsiding, side that it is subsiding, so it's going to form stresses on it. This concrete is going to go down, this one also goes down, and you get a lot of. So this is the mechanism of crack formation, that is shrinkage crack formation on the concrete. Hence we get cracks like these. Now, these cracks are generally forming on the surface of aggregates, and majorly they are parallel to each other. You can see here the the cracks are parallel to each other. Now this might be because you have steel in this direction, and if you have aggregates which are larger ones, you're going to find cracks on the aggregate surfaces. So these cracks generally are observed to be parallel to each other. The depth of the crack can be in the range of 25 to 50 mm, and the spacing between the two cracks can be in the range of 330 centimeters to even 1 meters. So these shrinkage cracks, when they occur on the surface of the concrete, they are going to cause deficiencies in the concrete. They're going to cause deficiencies in terms of durability characteristics of the concrete. We're going to discuss that in the latter part, how carry out creates deficiencies. Now, before we move to the deficiencies or effects of the plastic shrinkage, we're going to discuss about the causes of this shrinkage. And as we have discussed in the earlier part, that the shrinkage happens because of the water loss. You lose the water from the concrete, you're going to lose the volume which was held up or which was occupied by the water, so that much subsidence will occur. Now water loss can happen because of bleeding. The water will bleed up to the surface of the concrete, which will cause the loss of water. Another important factor is evaporation losses. So if the rate of evaporation is more than the rate of bleeding, obviously you're going to have a lot of water requirement on the surface, and we are going to have water loss. The very high water loss can be there. So one guideline which was provided by the course is, if the rate of evaporation is more than 1 kg per meter square per hour, we're going to have a lot of plastic shrinkage cracks forming on the surface. Another thing is, water will be absorbed by the formwork or by the PCC, which is below the RCC element. So if the water is absorbed by the formwork or by the subgrade of the aggregate, subgrade of the concrete, it's going to form plastic shrinkage cracks. Again, the similar sort of mechanism occurs, but now it is occurring on the surface of the formwork. That is the that is non-exposed surface of the concrete will be subjected to shrinkage here. Another uh, important cause of plastic shrinkage is bulging of settlement, or bulging or settlement of the formwork. If the formwork is not strong enough, it's going to bulge out and it's going to cause volume changes in the concrete. Now the concrete near surfaces, if it becomes too stiff, but if it is not strong enough to withstand the stresses caused by the shrinkage, which is a restraint that we discussed in the earlier part, so that can again cause shrinkage of the plastic shrinkage in the concrete. The Portland Cement Association have given